Well, first of all, thank you for attending my talk about React Native, cross-platform, and beyond. First of all, I want to apologize that I'm not Ken Wheeler, but I hopefully he can kind of do a good job filling in for his spot. So again, my name is Nader Dabit. I do React Native development, React Native consulting, and React Native training. We also have a podcast called React Native Radio. So if you're interested in hearing about React Native specific topics, check out our podcast. We have about 80 episodes so far covering a bunch of different things. So today I'm here to talk about my topic, which is cross-platform and beyond. Really what this talk is going to be about, it's going to be kind of talking about all the different ways that we can build beyond iOS and Android using React Native and what the APIs look like, how to create the projects, how to run the projects, and things like that. So I really got interested in React Native early on because of this opportunity to take my existing web skills and kind of take those a step further and start building more performant mobile apps than I was able to in the past. And the apps that I was building in the past were Cordova apps, and they were kind of using PhoneGap, and they weren't truly, even close to being real native apps. They were just web views. So when React Native came about, me and a lot of people, and everyone here probably, kind of noticed this huge opportunity. We can kind of use the existing skills that we have. We just need to learn React, and then we can start building a lot of different platforms, just kind of using the existing knowledge we had. So it's basically, a safe bet, just kind of spending the least amount of time to learn the least amount of things, but being able to do the most amount with those. So while React Native was only able to target iOS at first, and then a few months later, maybe a year later, Android, we've actually come a long way since then. And now we're able to target Apple TV, web, Windows, Mac OS, and even more. And with the newer and emerging platforms, we're starting to see kind of a new paradigm of engineering team that kind of has sprung up around this idea. And the first time I really heard this idea put into like a cohesive statement and a really interesting talk that was given on this topic of kind of reorganizing engineering teams was by James Ide at ReactConf 2016. And his talk was called Team X Technology, and it's one of my favorite talks of all time. And if you go to YouTube, you can still watch this talk, and it's definitely something I've actually probably looked at about a dozen times or so. And he talks about this idea of like a cross-stack engineer. And a cross-stack engineer is basically an engineer that isn't focused on, or is not responsible for a single technology, but they're instead in charge of a single feature across a bunch of different platforms. So lines of ownership are instead, they're drawn between product features and APIs and not drawn upon operating systems. So in operating this way, you can basically have a single engineer implement features across multiple platforms, and you can ensure more consistent APIs and implementations across those platforms. And one of the biggest strengths that was kind of gone over, and what I've seen, is this idea of organizational liquidity. And this is basically being able to switch responsibilities and satisfy both the needs of the team as well as the needs of the developer. Because these days, developers are they're in high demand, but they're also kind of very hard to make happy, right? So people want to keep developers on their team. Good developers kind of are in high demand, so they can kind of switch companies. So being able to kind of have a happy developer will help your company in the long run because you won't have as much turnover. Also, it's kind of this idea of organizational liquidity. It's basically how easy is it for an organization to reorganize a team, because it's much easier to kind of take a decision and go from one implementation decision to another versus going from one native platform to another with native teams like iOS and Android. And we're starting to get to the point where we're starting to see this idea come into fruition. And I've kind of borrowed from his talk this first section that I kind of just went over, because I think it's really important. Because in my company, I've had the opportunity to kind of go around the world and work with a lot of companies, enterprise companies like Amazon, Microsoft, and Visa, and Army Corps of Engineers, but also startups. And they're starting to actually implement this idea in their companies and in their organizations. And it's not only about kind of saving money, but it's also about speed of development, and it's also about a lot of these other ideas we talked about, like the organizational liquidity and being able to iterate quickly and things like that. So basically, what this talk is going to be about, we're going to kind of take a look at what we can use today to kind of achieve this, and what up-and-coming platforms or up-and-coming tools are kind of there to help achieve this in the future. So what we're going to look at are going to be some React Native specific frameworks and some that are not React Native. So we're going to look at ReactXP, React Native Web, React Primitives, and also React Native Apple TV. But we're also going to take a look at Weex and Flutter. You've probably heard of React Native Web and React Native Primitives and React Native Apple TV. And you may have heard of ReactXP and Weex and Flutter as well. But ReactXP, if you haven't heard, it's basically a abstraction built on top of React Native from Windows, or from Microsoft, I guess you would say. And it also allows you to target not only web, but also Windows out of the box without any additional configuration. You just basically spin up a new app, and it just automatically works. Weex is a platform that, or I guess a toolkit or something like that, you might call it, that's very similar to React Native, but it's actually built by Alibaba, and it's very popular in Asia. Alibaba is using it in production in many of their apps. And it uses, instead of using React, it uses Vue. And Vue's becoming pretty popular. It's really a pretty nice development experience, actually, if you haven't used it. So I think that definitely is a contender. And also Flutter. Flutter is different than a lot of these other ones because it's not a JavaScript framework. It's actually a Dart framework. But with people starting to use types and TypeScript, things like that, Dart starts looking a lot like typed JavaScript. So if you've, and also if you've worked with Java, it's slightly similar to that, but really, to me, it really looks a lot like TypeScript. So I know you might be thinking, like, I'm a React Native guy. I've been a React Native guy for 2 years. And, you know, like, what are we talking about? Flutter, this is a React Native conference, Weex. Well, I think it's always a good idea to keep an eye on other things that are out there, because React Native is really great right now. We're able to ship apps. Things are, you know, just really good right now, right? I mean, business is good and all of this stuff. But things are going to come along. We can learn from these things and maybe even progress in the future to other things, you know? It's always a good idea to keep our minds open. And with me working with React Native, like, working with it for 2.5 years, I'm able to pretty much do anything. Like, I pretty much get a consulting gig, and we can pretty much accomplish everything we'd like to at this point. There are very few blockers that are, you know, serious blockers. So it was a really big change for me to kind of go from React Native to Flutter and Weex, because I had no idea what I was doing. And I haven't actually shipped anything in either one of these, but actually preparing for this talk, I had to pretty much understand them pretty well, do navigation, compile a project, run it, maybe even send it off to the App Store. So from here, we're going to kind of walk through all of these different APIs and all of these different frameworks and talk about how to spin up a new app, what the APIs look like, and what does the code look like. So I'm going to kind of switch away from this, this view here, and I'm going to actually mirror my screen because I'm going to be writing some code. So bear with me for a second. Whoops. All right, so Apple TV. The cool thing about Apple TV is it's already built into every React Native project at this point. All you have to do is basically spin up React Native project with either create React Native app or React Native init. You'll see a folder of, this is basically a new React Native Apple TV app. So if you go into iOS, you'll see now you'll have a tvOS project and a tvOS test project. So it's not really hard to run it at this point. You just basically open the Xcode project, And instead of targeting the original target that we're kind of used to working with, we're going to choose an Apple TV target. So here we have this drop-down menu, and we're probably used to seeing these devices here, iOS simulator, like iPhones and stuff like that. Instead, we'll just choose the tvOS and hit run, and basically that's it. You're ready to go. So it's pretty much easy, really easy to get going. It's already there. The target file is still index.ios.js, so everything you write in your ios.js file, like you've been doing, just works. The environment experience is very similar. You have the debugger, you have the simulator. Instead of running a regular simulator, though, you're running this Apple TV simulator. Looks like I have an error. And also, the mouse events do not work. So. So anyway, if this doesn't run, I'll kind of skip over it because it's not too important. We're actually going to be going over some other stuff. But basically, this project was created by, or kind of maintained and built by Doug Lauder. And Doug Lauder works with Salesforce. So it was pretty interesting to kind of talk to him and kind of see that Salesforce was spending time and money on React Native, which was really interesting. And we had him on our podcast last week. So if you want to kind of learn more about Apple TV, check out the last episode of our podcast. We talked to Doug for about 45 minutes and kind of go over everything. So working with Apple TV is already kind of there out of the box. So it's not really anything we have to install. It just kind of already works. Well, the next one we'll look at is React Native Web. So React Native Web and React Native Primitives, I believe there's going to be a talk about universal components or something like that, or universal React Native later. And you'll hear more about React Native Primitives, and we're also going to go over those as well. But they kind of fall into the same category. Basically, React Native Web brings React Native building blocks and touch handling to the web. So you're able to use views, text components, and things like images that we're used to using in React Native, and they just basically run on the web. Getting started with a new React Native web project was really tough for me, actually. I went to the documentation. I kind of, have checked it out over the, past year, 6 months or so, or whatever. But getting ready for this talk, I wanted to create a new project with the new React Native version, right? I wanted to use like the newest version of React Native, but React Native Web only allows you to use like old versions of React. So I was stuck at like the late 30s, early 40s of React Native. So I actually created a new project generator called Create React Native Web App. So all you have to do now to kind of create a new React Native web application that has web, iOS, Android, just npm install create rn web app, and then type create rn web app, and then the name of your project. So what that would look like would basically be something like this. And then you kind of get all of this stuff scaffolded for you. And I'm going to let that run, but I'm just going to go ahead and start one that I've already created. So if you want to run web, you just run npm run web. And the interesting thing about React Native Web is you basically are running the packager alongside the Webpack generator or whatever of your Webpack bundle. So you have Webpack running. It basically generates a bundle. And we'll take a look at the code real quick. So alongside our index.ios, index.android, we have this index.web, and we have a single entry point. It just comes with a single file called app.js, and we're able to kind of work with this single file across all the platforms. And the main difference when you're registering your web application, instead of calling just app.registry.register component, we're also calling app.registry.runApplication. Then we pass in a root tag, similar to how you do React DOM.render. You pass in the ID of the element you'd like to kind of target on your HTML. And then we have a web folder with an index.html that contains our bundle and our root. And then we should be able to just go to localhost 8080. And there we go. That's kind of what you get when you create a new React Native web project. And you also get the same thing, iOS and Android, it kind of just works. It's kind of really bare bones, but I think it's important to be able to get up and running with something quickly when you want to learn it. You don't want to spend 4 or 5 hours kind of banging your head against the wall, just reading documentation, old documentation. So I'm hoping to keep this project kind of like up to date. But yeah, that's really basically it. So like with React Native Web, we're about to look at React Native primitives. They're very similar. I would say the main difference is if you're kind of wanting to build something that is if you have a client that maybe wants like a mobile website, but also a desktop website and a desktop app, this might be a good choice. Then you can just kind of possibly create the mobile app, have it run on the web, and then have like a separate desktop version of the web app. So React primitives now. React primitives, Leland Richardson kind of created and maintains these primitives. And basically they're primitive interfaces that you can run across different targets. So all you have to do is basically install React primitives, and they're a drop-in replacement for React Native as far as importing goes. So instead of like importing text and view from React Native, you'll just import text and view from React primitives, image as well, and you're basically able to roll from there. And then instead of, if you're working on a web project, instead of working with divs and instead of working with spans, you'll basically work with text and view components. And the built-in components that come with React primitives right now are text, view, animated, style sheet, image, and touchable. There's a discussion about text input, but I think with text input, there's such a huge difference between mobile and web, or I guess native mobile and web, that they're kind of undecided about whether or not there's going to be a text input primitive. But I'll just kind of open a project to kind of take a quick look at what this also looks like. So I'm just going to check out our index.ios file. And here, we're importing style sheet, text, and view from React primitives as opposed to React Native. And that's really about it. You just npm install React primitives, and you're pretty much ready to go from there. Now, I would say if you're looking to kind of create or kind of have a cross-platform open source project where you want to have a bunch of UI elements, similar to like what we actually have React Native elements in our repo, and we're moving over to React primitives where we can. We want to be able to make sure that our components work across multiple platforms, so we're using React primitives. I think it makes sense to use React primitives in that scenario. It probably could make sense also to use it in a real-world web application. I just haven't done it yet, but from what I understand, it seems like a better use case possibly for like open source projects and things like that, or components that you want to expose. So the next platform we'll take a look at is Weex. So Weex is basically, again, similar to React Native, but it's built using Vue.js, and it's created and open source by Alibaba. Alibaba recently actually moved this project to the Apache Foundation, so it's no longer in their organization. It's now completely kind of open source and out there, which I like, you know. Also, the Alibaba people are very active in maintaining it. It's like Facebook is very active in maintaining React Native. It's powered, again, by Vue.js, but the main difference, I would say, is that it's kind of ships with different components than we're used to. They mirror web a lot more than React Native. So if someone's coming from web, they can still use anchor tags, they can still use divs, and they can still use things like that. There's a few minor nuances, like text components that are like, instead of using an H1 paragraph span, you just have a text. Another interesting thing, it does also target web out of the box, so you're able to target iOS, Android, and web. The way you're going to like work with the command line CLIs and stuff like that, they have two different CLIs. They have Weex Toolkit and Weex Pack. In my investigation and playing around with this, I've had a hard time figuring out where they're going with these two CLIs. I feel like they both kind of overlap quite a bit, but you need both of them to kind of create a new project. I feel like Weex and Weex Toolkit do very similar things. So, but I was unable to create a project and run it without having both of them. So I'm hoping they kind of pick or choose one or the other. So what does Weex Toolkit, or what does Weex look like? What does Weex code look like? Well, it's basically just view code with a few minor inconsistencies or minor nuances as well. We have basically a template, and then we're just wrapping HTML within the template. And then we have, like I mentioned earlier, we have like a text component that's not the exact same as web. But this code will run on iOS, Android, and web. So it's kind of interesting to be writing divs and mobile. It's interesting to be writing things like, you know, classes and mobile. But we're able to do that with Weex. I'm sorry. A few of the built-in components that we are used to are things like video, text, anchor, dev, things like that. And then we have other things that are not really web specific, like list, cell, scroller, slider. To create a new Weex project, we basically install Weex Toolkit and Weexpack globally, and then you just type in Weex, create the name of the app, change into the directory, install the dependencies, and that only gives you basically a web project that you then have to manually add each individual platform. So if you want iOS, you have to go Weexpack add iOS, Weexpack add Android, so on and so forth, and then you just run Weexpack run whatever platform you'd like. So I'll take a quick look at some code because we didn't see, all we saw was the template. There's actually JavaScript also that you're going to be working with. So I'll go ahead and open this project up and we'll take a quick look at it. One interesting thing to me was that everything kind of goes in this source directory, and we're working with .view files. We're not working with like .we files, because when Weex first came out, they had this .we file extension. Now you're literally able to write exact view code, and it kind of works. So we have this template that we looked at earlier. Then we have styles, just like we would in the web, with classes, which is really cool. And we're not using camel case, we're using kebab case. So this is really nice for people that are coming from the web, that are just wanting to maybe learn the least amount possible, or maybe it's just more consumable, you know, or maybe you like classes better. So it's pretty nice. And then basically we have a script tag for each component, and we have things like before mount, which is like, you know, component will mount for React or whatever. Then we have data, which is like state here. And then we have methods, which are basically any functions that you want to call. So I'm going to go ahead and run one of these projects. And while that's running, I'll continue here. So what we have going on, we basically have this method of onload. Actually, we're not going to worry about that. We're going to worry about this update method. And it's basically attached to this click handler on our main div. And update is basically going to update this target. And we're going to basically toggle the target between React Native EU and world based on the existing value. And then we're rendering the target here in these double curly braces, similar to Angular. And I think a lot of people actually, Angular 1, a lot of people actually say Vue reminds them a little bit of Angular 1. I like it much better than Angular 1 though. So when you run this, it basically will give you the option from the command line to pick which simulator you want. So I went ahead and picked iOS 7. And while that's going, I'm going to go ahead and check out some of the pros and cons, in my opinion. So pros, Vue.js is pretty cool. I like working with Vue. I don't like it as much as React, but I like it. And then we have the different targets. It's great that it does also target web out of the box. It's pretty easy for web developers to kind of get up and running because, again, like I mentioned, you use classes, you use kebab case for styling and things like that. Also, you're working with divs and stuff like that. The CLI is pretty good, so you don't have to worry about like kind of a lot of the intricacies of like working with the new project, it all kind of is already there for you. Just running the CLI commands with help and you get a bunch of info. It is very actively maintained and improved. So if you go look at the repo, there's a lot of action going on there. A lot of people are using it. It's very popular in Asia. It's not as popular here in the United States yet. I'm not sure if it will be because you'll hear about the cons here. Right now, there's no reloading or hot reloading. So if you want to reload a project, you actually have to compile the entire project from your command line. So if you want to make a small UI change, you have to run the project again. So we're missing one of the main reasons that we came to React Native. We're not having that quick refresh, though we are still using JavaScript. So the documentation is just nasty. I looked at it 6 to 8 months ago, and I shouldn't be. Maybe I should. I'm actually having some notes that I've written from this talk that I'm going to contribute. But the problem is a lot of the documentation is also in Mandarin. But I think they're trying to figure a way out to kind of have a little bit of both. A few things that I'm going to basically be updating in their documentation are kind of what my opinions are, the difference between Weex pack and Weex toolkit, so people can kind of have a slight better understanding, and basically just the bare bones minimum to get a new project set up, because while there is some documentation around that, there's about 7 different versions of it. So I think like having one new and updated version would be great. So I feel like React Native community and React Native in general, the people in charge of it have done a really good job compared to Weex as far as keeping up the documentation. And I know they've gone out of their way recently to kind of talk about people contributing to the documentation. So that's really good. The debugging experience is just not even there, really. There's a debugger, but to actually hook it up, you actually have to go into the native code and configure things like your ports, and then those change over the course of like a day sometimes when and you have to go back and change it again. So but there's also no like debugging in the sense that we have like React. We basically have React debugger, and we have just the built-in debugger where you can actually see styles. They don't really have that. And again, much of the documentation is in Mandarin. So that's good for people in Asia probably, but not really good for us. So this is basically what we have. We click here. We're getting that change, but basically this is just kind of a boilerplate project that you'll see if you kind of get set up with Weex. So my consensus on Weex, it's not yet quite ready for prime time. So we're going to look at Flutter and ReactXP. I'll kind of try to go quickly through this as I'm running low on time. But basically, the tagline for Flutter is easy and fast SDK for building apps, and it's built by Google. It uses Dart. It targets only iOS and Android, so there's no web. There's no future plans to do any other targets either. But because they focus on iOS and Android, I feel like they've done an excellent job at making everything work really well in iOS and Android. There is a nice CLI called the Flutter CLI, very straightforward. Creates a new project, runs a project. It works flawlessly, at least in my experience. Right now, Google's using it in its mobile sales tool, the Stores Manager, Google Shopping Express, and also they're building a bunch of new apps internally using this framework. It's still in alpha, but they're already using it in production. It ships with, the cool thing, this is one of the coolest things I like about it, it actually ships with Cupertino and material styling already built in, and it's very, very good looking styling. It's very performance styling. So if you want a widget that kind of has material design, you don't have to worry about going to like a third party that may never maintain it. They actually have it built into the toolkit, and it works really well. Something about Flutter, everything is like a widget, and widgets you can kind of think of as components, but the widgets are kind of nested hierarchically. So basically you have this tree of nested components that gets really, really large, which is kind of, I don't really like that part about it. A difference between React Native and Flutter is that it actually renders its own widgets or components as opposed to using components provided by the host operating system. Also, the Dart and Flutter team work very closely together. So basically, the Dart VM is really optimized to work with Flutter. What does an app look like? I'm going to go ahead and, whoops, went way too far. I'm going to go ahead and open up a code sample just to kind of take a quick look. And I'll also run Flutter run, see if I can get this going. First, need to go ahead and open a simulator. So this is basically what some Dart code would look like with Flutter. And basically, our project comes with an iOS and Android directory, a few configuration files. All the code for that project, though, is going to be living in this main.dart file in the lib folder. With Dart, you have a main function that basically is the entry point for your app. And here we have main, and then we're calling run app, and we're passing in this class here, my app. I'm going to go ahead and go down to where some of the actual creation of the component that we're going to be looking at lives, and delete some of these comments. Whoop. There we go. So basically, our main UI is going to be kind of built right here. We have this build function, and we're returning something called a scaffold. And a scaffold is basically a widget. You could think of this as like a container or something like that. And we pass in a few different pieces of configuration. We have a body, we have an app bar, and then we have a button. And you can pass in as many different components as you'd like to these different widgets or whatever. So we have, when we want to render text, we call new text. So instead of like wrapping text in JSX, we're calling like this new calling text. So like the paradigm is much different than React Native. It's much different than React. It's actually a lot of new stuff to learn. The styling is so nice with Flexbox. I'm so used to it with React Native and React. It's kind of really, it was really tough for me to kind of learn how to do anything with this. Let me see if I have an error. Looks like, Let me try this one more time, and if not, I'll skip over it. I think maybe the device is too old. Try one more time. It's not, my simulator is kind of messed up right now, so I'm not going to worry about that. But this is basically what you would get from a new project. The app bar is that top bar, the button is that bottom right button, and so on and so forth. I guess one other interesting thing is how you call a function. So we have this idea of set state, which is pretty cool because we're already used to that a little bit. And we're calling increment counter. And then we have this onPressed function, and then we're kind of attaching to that increment counter. So a bunch of built-in components, container, grid view. But the thing is, with this framework, the API surface is actually pretty massive. If we go to the documentation and we look at the widget catalog, actually that's probably not the best place to go. That's just going to show the components that are UI components. I'm not going to look at all of the documentation right now, but the API surface is really big, but the documentation is like pristine. They have everything that you could possibly think of in their like documentation. They have examples, and the examples are set up really nicely so you can like walk through step by step and kind of learn stuff. It literally only took me about 2 hours to get up and running and create like a CRUD app using Dart, and I've never written Dart before, so it's really nice. So check it out. To create a new project, you install the Flutter CLI, you do Flutter create, then you change into the directory, of course, and then you just type Flutter run. The pros, well-maintained, fantastic documentation, probably some of the best documentation I've ever seen. It has pretty much every API you can think of built already into it. I'm thinking it must have like hundreds of components and APIs already kind of built into it, and it's still in alpha. It has built-in UI libraries like Material Design and Cupertino. The developer experience is really nice. We do have hot reloading. We do have live reloading. Also, Dart is mature. Dart has been around since 2011, so it's been around for 6 years. It's not something new that they're kind of just playing around with. It's pretty, it's very mature. The cons, it's a completely new framework to learn, all new APIs. The styling is very hard to kind of learn. You do need to understand Dart. The API surface being huge is a good and a bad thing. It's good because you can do anything you like without having to hack anything. It's bad because you have to learn it. Unfortunately, it only targets iOS and Android right now, but I think that's a pretty nice niche to be in if you're looking for, if a company just wants to build an iOS and Android app, they're not worried about web. These people are focused on iOS and Android, so they've optimized it to work really well, and it's actually extremely performant. I believe that I talked to Sankit from Native Base, and he did some type of performance kind of comparison, and I'm interested to kind of look at that. It's also still in alpha. So my consensus for this is basically it has a really bright future, and it really has a really good development experience. It reminds me a lot of React Native when I first started using it. I was excited about it. I'm pretty excited about Flutter. I still can't say I'm going to use Flutter in a project anytime soon, but if I have an opportunity to use it in a client that kind of would like to check it out, I'm definitely going to talk well about it. So that kind of brings us to the very last project, or the last toolkit we're going to look at. This is ReactXP. ReactXP, created by Microsoft. It ships out of the box with iOS, Android, web, and also Windows. Right now, Skype is built using this ReactXP, the new Skype mobile app. And the main difference, I guess, is it has a slightly different API surface, and it uses TypeScript. And you don't have to use TypeScript, but it kind of highly encourages it, and it has all the types kind of built in out of the box. So ReactXP looks very similar to React Native. The main difference is instead of using text and like views and things from React Native, we're importing them from ReactXP. Another difference is the styling is configured in a way that's I wouldn't say quite different, but it's a little different. So I'm going to take a look at the styles because it's really the main difference, I would say. So here, when we work with styles, instead of saying stylesheet.create, we're saying styles.create scroll view style, styles.create view style, and styles.create text style. So every time you create a different component, you actually have to use a different API for creating your styles. Other than that, everything else is really the same. You have component did mount, component will mount, render. You have everything that we've been using in React. So jumping into ReactXP from React Native was really easy. Built-in UI components are things like that we're already kind of used to. Yeah, okay, I know we're getting way far on time. So to create a new ReactXP project, we also have a generator for this on our open source repo along with all of our other stuff. You just install create XP app, and then you type create XP app, and then that's it. I'm going to kind of skip over the last two slides for this, but basically I really like ReactXP as well. Not as much as React Native, but I feel like they're really maintaining it, and I feel like it's going to be something big in the future, or maybe an option in the future, who knows. Anyway, follow me on Medium, Twitter, and GitHub, all at Dabit3. Go to React Native Training GitHub repo and find a bunch of repos that you like and star them. Thank you for listening to my talk.